Hello, everyone, and welcome to lecture 13. In the last lecture, we explored systems thinking, feedbacks, thresholds, and resilience. Today, we apply those ideas at the largest possible scale, the planet itself. And we will look at two complementary frameworks, the planetary boundaries framework and the concept of socio-ecological systems, something we did touch upon in the last class, but today we explored at how they are connected to everything we have covered so far in module 2. Okay, the first is the planetary boundaries framework. And let me also just tell you that these are a bit complicated concepts, and therefore I would also suggest readings for you. So do read those so that it becomes much more clearer. And of course, if you have questions, I will be happy to respond. Okay, so what is planetary boundaries framework? So in 2009, Johan Rockström and a team of 28 leading Earth system scientists published a landmark paper in journal Nature. And their central argument was this, that human civilization has thrived for roughly 10,000 years within the remarkable stable conditions of the Holocene epoch. So what is Holocene epoch? It's the geological period since the last ice age. That stability is not an accident. That's what they argue. And it is maintained by a set of Earth system processes that regulate planet's climate, chemistry, and biosphere. Rockstrom and colleagues identified 9 such processes and argued that each one has a boundary, a level beyond which human interface risks pushing the Earth system into a new, less stable, and far less hospitable state. Remember what I spoke about in the last lecture about threshold. So if you cross that threshold, you will push it to a very new system. But what they argue is that it will be new, but it will be less stable and far less hospitable state than where we are. They call the space within all 9 boundaries the safe operating space for humanity. So now let me briefly introduce each of these 9 boundaries. Climate change, measured primarily by atmospheric carbon dioxide concentration. The proposed boundary is 350 parts per million. Biosphere integrity, which encompasses biodiversity loss and the rate of species extinction. Land system change, measured by proportion of Earth's land surface covered by forests. Freshwater, measured by consumptive freshwater withdrawal from rivers, lakes, and aquifers. Biochemical flows, particularly the cycles of nitrogen and phosphorus, which are massively disrupted by synthetic fertilizer use. Ocean acidification, measured by saturation state of aragonite, that is the mineral that marine organism used to build shells and skeletons. Atmospheric aerosol loading, which affects monsoon systems and regional climate patterns. Stratospheric ozone depletion, which regulates ultraviolet radiation reaching the Earth's surface. And novel entities, a category that includes synthetic chemicals, plastics, and other materials that did not exist in the pre-industrial world and for which Earth system have no evolutionary experience. As of the most recent assessment, 4 of these 9 boundaries have, as you see on the slide, have already been exceeded. And which are those? Climate change, we know about it, biosphere integrity, land system change, and biochemical flows. So we are not approaching these limits, we have actually crossed them. And this is the context in which all ecological economics must be so far understood. So we have been talking about the scale, the limits to growth, etc., and that the economy is a subsystem of a larger ecosystem. But you can clearly see that if you don't think in that lens, we are not just approaching limit. There are certain boundaries which we have already crossed. Now let's move to understand that what is this safe operating space, and we call it something like, what does it actually mean to be inside versus outside the planetary boundaries? Because in the earlier slide, I explained to you that we have already crossed the boundary, right? So now this is important to understand, what is being inside and what is about being outside the boundary. And let me be precise about this because the framework is sometimes misunderstood. So when we are inside the safe operating space, when all the 9 boundaries that I just explained to you are respected, the Earth system remains in a state broadly similar to what it was, what we call it as the Holocene. That is something that I explained, like the geological period since the last, ice age. Now, but biochemicals processes remain stable and predictable. Feedback loop we identified or we discussed in lecture 12, the climate system, the water cycle, the climate cycle, etc., remains in a balancing loop, dominated regimes. Human civilization can function and develop because biophysical foundation it develops are on are stable. Risks, though they exist, are broadly recoverable. There are, of course, risks. You do not live in any world where there is no risk, but they are recoverable, right? So that is about operating within the system, operating space, remaining inside the safe operating space. Now, when we move outside a boundary, the situation changes qualitatively, not just quantitatively. The risk of abrupt, non-linear, and potentially irreversible change increases sharply. If we remember tipping points, the threshold we discussed in lecture 12 may be triggered. And here is the element that makes the planetary boundary framework so important, that the boundaries are not independent of each other. Crossing one boundary can push other closer to their own threshold. So remember, they're interconnected, right? Think of the systems thinking that I explained to you in the last class. So climate change, for example, accelerates biodiversity loss, which undermines the biosphere's capacity to regulate carbon cycle, which further then accelerates climate change. Deforestation for agriculture disturbs. So when you are deforesting for your agriculture, what does it do? It disturbs the regional rainfall pattern, then which stresses the freshwater systems, which further degrades terrestrial biodiversity. The interactions are like numerous and many are not yet fully, in fact, understood. That's the biggest problem. We do not really understand the whole system. Suppose if I am someone who only understand climate change, and I would not understand how the biodiversity, terrestrial biodiversity functions. If I am somebody who understands forest resources, would not understand how the carbon cycle operates. So there are many interconnecting loops which are yet not fully understood. This interconnectedness means that the safe operating space is not simply 9 separate limits, It is not that, oh, I am still here, fine, I have out of 9, I have only crossed 4, so I'm good. It's not like that. It is a system of interconnected constraints, and breaching any one of them weakens the integrity of the entire system, the entire whole. Cascading effects across boundary undermine the foundation for human well-being in ways that may develop slowly, but ultimately it proves irreversible. So 4 boundaries are already exceeded as of 2020, 6. We are conducting, so what it also means is that we are conducting a global experiment without controls in what happens to human civilization when it operates outside its safe operating space. So this is something that is yet to known. When we cross all the limits, how it would be to operate outside that safe operating space. Now, this is where the planetary boundary framework tells us about the biophysical limits within which humanity must operate. But it does not by itself tell us how society actually interact with those limits. So far, we only spoke about the planetary boundaries, but those who makes decision, who interests are served, whose knowledge counts, and why some communities manage shared resources sustainably while others do not. All of these are understood under the concept called socio-ecological systems, which again, something we did touch upon in our last lecture. But today, let's discuss this in a bit more detail. So a socio-ecological system is an integrated system in which social and ecological components, as we discussed in the last class, are coupled and they co-evolve over time. They evolve together, the social system and also the ecological system. Now, ecological component includes all the biotic and abiotic elements which we had discussed in this module earlier, that is soil, water, climate, ecosystem processes, services, etc. So you know everything now. What is an abiotic and biotic, resource? The social component includes institutions, governance structures, cultural values, economic arrangements, power relations, livelihoods, all of these that people, derive from the ecosystem. So these two components do not merely influence each other, they are fundamentally entangled. I mean, I think I don't have to explain this to you, that why livelihood and water is connected, why livelihood and ecosystem is connected, or for example, why economic, cultural values and ecosystems is connected, right? So we all know that they are fundamentally entangled. They shape each other continuously through feedbacks, adaptation, and also co-evolution. The theoretical foundation of SES framework, the socio-ecological systems is also known as SES framework, was laid by Eleanor Ostrom. I'm sure many of you know who she is. She received the Nobel Prize in Economics in 2009, and the point to note, the first woman ever to do so, and for her work on the governance of shared resources. Ostrom's central finding, developed through decades of empirical fieldwork, was that standard economic prediction. What is that standard economic prediction? That shared resources would inevitably be overexploited in what, Hardin called the tragedy of commons, was simply wrong as an universal claim. That's a very interesting point she makes. She makes that this is not correct to say that every shared resource would see tragedy of the commons. Now, to understand this, you need to, of course, go through tragedy of commons, what it is. I hope you have already done so, but I cannot explain the entire thing here. But it is about that nobody think about maintaining the common resource because it is assumed to be others' responsibility, and as a result everybody sends their cow for grazing in that land, and as a result the land degrades and everybody suffers together. So this is why they call it as a tragedy of the commons. But she said that you cannot make it as an universal claim. Communities around the world had sustainably, and often for centuries, they had actually developed sophisticated institutional arrangement for managing these shared resources sustainably, and not just for a day or two, but for over years, over centuries. What determined whether they succeeded or failed was not the nature of the resource alone, but the interaction of the resource system, the resource unit being harvested, the governance system, the users. And crucially, none of these could be analyzed in isolation from others. So Ostrom's framework gives us the analytical tool to understand why some socio-ecological systems are resilient and others are not. So it's very important that you can read this framework because it's a very interesting and an important framework which clearly indicates that how society and ecology interact, and this interaction does not always has to be negative. There are various ways, the way the interaction happens, the kind of governance system there, the local knowledge, all of these helps to actually restore them and to build resilience, make these systems much more resilient. And wherever this kind of interaction, the positive interaction, does not exist, there you would see that the systems are not resilient. Now, connecting, what is important is now how do we connect the planetary boundaries with SES? So the real analytical power comes here, to connect these concepts. And so let me just quickly walk you through 4 dimensions of that connection. So the first is scale. I mean, now you know everything about scale. You have been hearing about scale from day one of this lecture. But here, let me just explain to you in a more detailed way that planetary boundaries define biological envelope within which all socio-ecological systems must operate as something that is very important. That's the scale, right? The planet. So far, when we spoke about scale, it was probably a bit vague for you. Now you know that what we talk about here is the ecosystem, the planetary boundary, under which the socio-ecological system will ultimately operate. No SES, no matter how well governed, how adaptive, how culturally rich, can survive indefinitely outside this safe operating space. If you are within, then it is fine. Even if you are best SES, still it would not survive it is if you have already crossed the limit. The boundaries are not merely global averages. They set the conditions that determine whether local and regional SES can function at all. A fishing community with excellent governance and deep ecological knowledge cannot sustain its livelihood if ocean acidification destroys the marine food web. Right, because they would still need that food. So it's happening somewhere else. You have an excellent system in place that the fishing community is managing that relationship well, but through some other reason, there is ocean acidification that has destroyed the marine life that would destroy the food web. or if climate change eliminates the monsoon rainfall that drives the river flow and nutrient cycle, will also have an impact on that fishing community. The global biophysical context is the ultimate constraint within which all the local socio-ecological dynamics play out. So it is important that while locally these are all good, but you also have to remember it's a system. If climate change happens for something like big industries are emitting, it will also have an impact on the best socio-ecological system as well. The second dimension is governance. The planetary boundary framework tells us what the limits are, but it does not tell us who decides how close to a boundary we go or on whose behalf we go. This is where SES perspective becomes essential. So you saw why planetary boundary matters for SES. Now we try to understand how governance system is so important. So governance system, from local resource management institution to national regulatory body to even international environmental agreements, determines whether boundaries are respected or transgressed. And those governance systems reflect power relations, distribution of knowledge, cultural values, and also historic institutional histories that vary enormously across contexts. So the planetary boundaries are ultimately a governance challenge as much as a specific one. So the question is, okay, we need to work within the planetary boundary, but how do we decide, how do we govern ourselves within that? And that's why the governance system becomes very, very important. The third dimension is feedback. The SES concept makes explicit what the planetary boundary framework implies. Social systems drive ecological change, right? We drive these ecological change, and ecological change feeds back into the social system. Like for example, climate change, which is crossing the climate boundary. So when you have climate change, you have already crossed the climate boundary, disturbs agricultural productivity. Disrupted agriculture generates food insecurity. Food insecurity drives migration as people move from affected rural areas to cities or across borders. Migration and competition for resources would generate political instability, which we are already seeing across the world. Political instability may weaken the governance institution, the same very governance institution which needs to actually respond effectively to climate change. Now, weaker governments means less effective migration and adaptation, which allows further climate change. This is a reinforcing feedback loop operating at the scale of civilization. And it is not really hypothetical. It is already unfolding in many parts of sub-Saharan Africa, the Middle East, and also in South Asia. So you see, this is what is the feedback. And the fourth dimension, we discussed about it a bit, is the resilience. The resilience of a socio-ecological system, its capacity to absorb disturbance and continue functioning, right? Remember, with what we discussed in the last class, resilience is not that it resists change. It's about what is the capacity to absorb that disturbance but still continue functioning. Depends on both dimensions simultaneously. It depends on ecological buffer capacity. That means how far are we from the planetary boundaries, how much ecological redundancy and diversity it retains, how intact its ecosystems are. And it also depends on social adaptive capacity. It retains how intact this ecosystem, so basically it's also, so one is that it depends on the ecological buffer, the capacity, the ecological capacity to sustain these disturbances. And it also depends on the social adaptive capacity, the strength of institutions, the diversity of knowledge systems, flexibility of governance arrangement, and also the quality of social trust and cooperation. So resilience cannot be built in only one dimension. A socially adaptive community, if it is sitting on a severely degraded ecosystem, has little to work with. Right? So it's not that, okay, we are highly adaptive, but we don't have any ecological adaptation. Then it doesn't make any sense. So an ecologically intact landscape, again, governed by rigid, non-adaptive institution, will not respond effectively to any stress. So both the dimension, the ecological resilience and social resilience, both must be actively maintained. So only then we would be operating within a safe planetary boundary. So now let me close by again bringing together the key takeaways from today's lecture. First, the Earth has a biophysical limit, which we know already. The planetary boundary framework gives us most scientifically grounded articulation of what those limits are, the safe operating space within which human civilization can flourish. This is not a political or ideological claim. It is a scientific one grounded in Earth system science. Second, four of those boundaries are already exceeded. We are not approaching the edge of the safer space. In several critical dimensions, we have left it. We are out of that safe operating space. This is genuinely novel territory in the history of species because it have never happened earlier, and we should take its implication therefore seriously. Probably we are not well prepared, and we do see that we are not. Third, the boundaries are interconnected. Exceeding one does not simply increase risk in one domain, it amplifies risk across multiple systems simultaneously, though the kinds of cascading feedback that systems thinking prepares us to recognize. So we need to use, therefore, the lens of system, because through that only we can understand this cascading feedback. Fourth, social and ecological systems are inseparable. They co-evolve and are codependent. Analyzing economic behavior without reference to ecological system, or managing ecosystems without referring to social institutions and power, both lead to systemic failure of understanding and policy. Fifth, governance power and institutions determine whether we stay within safe limits. Science of planetary boundaries can tell us where the limits are. Whether we respect them is a question of politics, institutions, culture, and values, and ultimately of the kind of socio-ecological systems we choose to build and maintain. Now, for your reading, I want to draw your attention to four essential papers. You can see the original paper, 2009, which was published by Rockstrom et al. In Nature, which is called A Safe Operating Space for Humanities, is one of the most cited and influential paper in environmental science for the past 2 decades, and it is absolutely an essential reading. 2015 update by Stephen and colleagues in Science, Planetary Boundaries, also a very important one. I've also added Elena Alstrom's 2009 paper, A General Framework for Analyzing Sustainability of Social-Ecological Systems. Then 2010, a paper by Folke and colleagues in Ecology and Society on resilience thinking and transformability. Now, the thing is, you need to go through these papers. They're important because they all talk about each of these elements that we have tried to bring together in today's lecture. Okay, so again, I have kept a question for discussion or for you to think, and that is about, which planetary boundary do you think poses the greatest risk to socio-ecological systems in South Asia specifically, and why? Why do you think so? All right, then. So I'm going to end here for today, and we will meet in the next class. Thank you.